given some polynomials, we should be able to identify what their zeros are, and by doing so we can sketch graphs of what they might look like. So we're going to find all the zeros of these, and then we're going to sketch graphs and verify that graphically using our graphing calculator. So if I need to find the zeros, the most efficient way to do this is to factor, because factoring is going to get into factored or intercept form. So I'm going to do my very best to factor these things to the best of my ability, and then when if I can't factor it, then I'll try to use other methods, like the quadratic formula or something to find any more zeros. So let's see. I see stuff in common. I see 3's and x's in common. I think this is like 3x. Then when I factor to 3x, I'm left with x squared minus 4x plus 1. So right away I know one of the zeros is 0. There are 2 more though, because this quadratic we can do more with this. We definitely can't factor this anymore. So maybe we check to see if there are any more zeros of this, maybe using the discriminant. So b squared, let's check if there are any zeros left, any more real zeros left here. Let's see, the discriminant, let's check b squared minus 4ac. So negative 4 squared minus 4 times a times c. That's 16 minus 4, which is 12. There are 2 more real zeros because this discriminant is positive. To find them, I think if we want to know what they are exactly, we're going to need to use the quadratic formula. Which isn't so bad, because I've already figured out the discriminant. This goes underneath the square root in the quadratic formula. So quadratic formula, a equals 1, b is negative 4, c is 1, x equals negative b plus minus the square root of b squared minus 4ac, which we've already calculated to be 12, over 2 times a. So this is 4 plus or minus the square root of 12 over 2. It turns out the square root of 12 is 4. 12 is 4 times 3. It's 2 times 2. That means 12 is 2 square roots of 3. So this is 4 plus or minus 2 square roots of 3 over 2. Or if I divide everything by 2, 2 plus or minus the square root of 3. So I think the 3 roots are 0, 2 plus the square root of 3, 2 minus the square root of 3. We found them algebraically. Let's verify these graphically. So let's make a new graphs page. Let's graph 3x cubed minus 12x squared plus 3x. There are definitely 3 zeros. Let's see if we can, maybe I'm going to zoom in. You'll see these a little bit better. And I'm going to use, on my calculator, on Inspire, I'm going to use Analyze Graph and find the zeros. On your 8384, it's in the Math menu. You're going to use the zeros function. I'm going to highlight. And, well, there's one of them. X is 0, output 0. So x equals 0 is one of the zeros. That's good. That's what I thought. The other 2, I'm going to get decimal values of, and I'm going to compare them against I'm going to compare these decimals against what 2 plus square root of 3 is and what 2 minus the square root of 3 is, just to be sure. So let's see, what is 2 plus the square root of 3? 3.73205. 3.732. There's 2 plus square root of 5 and 2 minus square root of 3, 0.267949, 0.268. Bingo. So we verified them graphically. Here are the roots. Let's try it again. Let's see. How can I factor this 4-term polynomial? Well, you could use you could factor by grouping. You could use a box, whatever you want. There are 4 terms. Maybe I'll use a box because I can. And I have the space. X cubed plus 100. See what's in common. There's an x in common. There's a 4 in common. There's an x squared. There's a 25. And I think I need these boxes to be negative, so I think the most efficient way to do that is to make both of those a negative, because negative times a negative will give me a positive. So this is equal to x minus 4, and then x squared minus 25. And what jumps out at me is that this is a difference of 2 squares. So this is really x minus 4, x minus 5, and x plus 5. So it looks like I have 3 roots, or 3 zeros, which are 4, 5, and minus 5. And we'll check that graphically. I think we're going to be correct here. How about x to the 3rd power minus 4x squared minus 25x plus 100. Looks to me like 4, 5, and minus 5, but we'll confirm just to be safe. Negative 5, 4, and 5. Okay, and last one. Same game, let's factor this best we can. It looks like I think a 2 and an x squared are in common. And when I factor that out, I'm left with an x to the 4th. I'm left with a minus 5x squared with a plus 6. So I have 2 factors already, 2x squared and this. I think that there are, this has the same structure as like y squared minus 5y plus 6, just there's x squareds in there. So I think if I think I can factor this. I think I need to find numbers that multiply to 6 but add to minus 5. I think that's negative 2 and negative 3. So, I think that I can, if I'm willing to use square roots and not just whole numbers, I can factor these further. Or you could just set each of these equal to 0 and solve, and you'll find 2 solutions. The 2 solutions have to be positive and negative square root of 2, positive and negative square root of 3, and 0. So I think there are 5 distinct roots. I think this one's actually going to be a repeated root of 0. But I think x equals 0. Again, you could solve, you could say x squared minus 2 equals 0. X squared equals 2 plus or minus the square root of 2 is a root. And same game here, x squared minus 3 equals 0. X squared equals 3. X is plus or minus the square root of 3. So I think we're going to see 5 distinct roots. Although we would say that 0 is a repeated root because the square root of 0 plus or minus 0 is the same number. We'll graph it just to confirm. So one last graph here. 2x to the 6th minus 10x to the 4th plus 12x squared. And what do you know? It looks to me like there's 1, 2, 3, 4, 5 roots available there. Maybe I'll zoom in just a little bit. see all 5 of them. And the reason, again, you kind of see graphically why we say that zeros are repeated roots, because it's like where if this were to scoot down any little bit, there'd be 2 more roots there. So we say, since this graph is what we say is tangent to the x-axis, we say that counts as like what's called a double root. But let's find what those are. Again, 0, unsurprising. One of these should be the square root of 2, which is about 1.414. What do you know? 1.414. And if memory serves, square root of 3 is like 1.67-ish or so. I might have that third decimal wrong. 1.732. And just to confirm, the square root of 3 is about 1.732. 1.732. And also those should be the negative versions. Negative square root of 2 and negative square root of 3. So those are our 5 distinct roots, and we verified them graphically on our calculator.